1.3 Prime Factorization. A factor pair is where we have two numbers whose product equals a definite number. So 3 and 4 are factors of 12. They are a factor pair because when we multiply them, we get 12. So 3 and 4 are a factor pair of 12. We are going to find the factor pairs. For 36, when we have numbers and we're looking for factors, every number has a factor of 1. So I can always start with 1 and the number. So 1 and 36, I know it's even. 2 and 18. I can have 3 and 12, 4 and 9, and 6 and 6. I keep going, checking all the numbers until I get one that is either the same, so it's a perfect square, or when I keep checking, I start again going up on the other side. So when these match, or there's nothing in between these bottom ones, I'm done. For 28, we have 1 and 28, 2 and 14, 4 and 7, 5 and 6 do not go into 28, and then I'm back to 7, so I'm done. For 11, we have 1 and 11. Now, 11 is something that we call prime, where its only factors are 1 and itself. I cannot find any other numbers, any other whole numbers that go into 11 to make 11 as the product. If they are not prime, we would call it composite, where it has multiple factors, more than just 1 in itself. And 50, we would have 1 and 50, 2 and 25, 5 and 10, and then 6, 7, 8, and 9 do not go into 50. So that's all. Now we have prime factorization. And prime factorization is the product of a number's prime factors. To get the prime factorization, we're going to make something called a factor tree. That is where we split the number into factor pairs until we have only prime numbers left. So we're going to find the prime factorization of 45. I know 45 is 5 times 9. 5 is a prime number, so I'm going to circle it and know that this branch of the tree is done. 9, however, is composite, and 9 is 3 times 3. So to write the prime factorization of a number, we would have 3 times 3 times 5. And we typically write these prime factorizations in order from the smallest number to the greatest, everything being multiplied. If I were to multiply all these together, I'll end up at 45. That's how I can check my work and know that I did it correctly. But we know with exponents that we can rewrite 3 times 3 as 3 squared. So using your exponents for repeated prime factors is the best way to write your answer. For 54, I can have 6 and 9. 6 is 2 times 3, and 9 is 3 times 3. So here I'd have 2 times 3 times 3 times 3, which is 2 times 3 to the third. For 64, I know that is 8 times 8. 8 is composite, and 8 is 2 times 4, and 4 is each 2 times 2. So all these numbers I have at the ends here are 2's. So this is 2 to the 6th power. And for 80, I can have 8 times 10, and 8 is 2 times 4, and 4 is 2 times 2. 10 is 5 times 2. So I have 2, 2, 2, 2, and a 5. So that's 2 to the 4th times 5.